Hey guys, this is Hassan and welcome to my channel Hassan Academy. Today we are going to learn a very important topic from inorganic chemistry, that is bond angle. Okay, so either you are a IIT JEE aspirant or NEET aspirant, this topic is very important for you because every year they are asking at least 1 to 2 questions from here. Okay, so one thing I want to tell you here only that there is no any direct formula. You just use that and you are getting bond angle. No, they will ask 3 to 4 different compound and they will ask the comparison. Which one is more, which one is less, decreasing order or increasing order. All this. For that, you should know 2 to 3 different concepts. Sometimes even more, but at least 2 to 3 concepts you should know so that you can use those and you are able to find out their bond angle. You can compare. Okay, so one thing is hybridization. You should know their hybridization. Based on that you can separate. Another second thing is VSEPR, valence electron pair repulsion theory, that you should know so that you can tell that due to lone pair which one is bond angle going to reduce and increase, all these things. Okay, number 3 is NBEPR, non-bonded electron pair repulsion theory. Okay, many one is don't know that concept and they are just telling those molecule it is exception, it is exception. There is no exception actually, that is under NBEPR. Okay, and last one of the important thing you should know is Dragos molecule. Okay, what are the Dragos molecule and what are the importance for Dragos molecule in bond angle? I will tell you definitely all these things. Okay, so number one thing we are going to learn, that is hybridization. Number two is VSEPR, valential electron pair repulsion theory. Number three is NBEPR. Number four will be Dragos molecule. Dragos molecule, and at the end I will give you some tips to find out the answer in competitive exam very easily. Okay, one by one we will do. So let's go for hybridization. Before that, if you want to know what is bond angle, it is angle between two bond, as simple as that. Okay, so suppose you are we are talking about water molecule, OH, definitely two lone pair also there. So this angle we are going to talking about bond angle. You may ask that this lone pair and this bond pair also making one angle, why you are not going to talk about this, and either if they ask you. So generally if they said that bond angle, they are going to mention angle between two bond pair only, this one only. Okay, if they are interested for this angle, then at that time they will mention in question that angle between lone pair and bond pair, like that. Okay, so whenever we are talking about bond angle, angle between two bond. Okay, so let's start with hybridization. So I'm not going to tell all the things what is hybridization and all these things. It will take at least 1 to 2 classes. No, we are going to only tell you how to find out the hybridization. By the way, hybridization is the mixing of orbital. Okay, hybridization how to find. So there is different method is there. Everyone using different method. I will show you the easiest one and which one is more helpful for you. Okay, because from that you can find out the lone pair, bond pair, sigma bond, pi bond, everything. Okay, suppose one molecule, let's take as H2O. So here you should know central atom. What is central atom? Oxygen. So central atom valence electron how many? 6. That much you should know. Then rest of the things you can do. 6 electron is there. Let's arrange here 1 2 3 4 5 6. After that 2 hydrogen, they will make one bond and 4 electron is left. This 2 is together one lone pair, this 2 is another lone pair. So steric number you have to find out. For steric number you have to count only sigma bond plus lone pair. Sigma bond how many sigma bond? 2 sigma bond plus lone pair how many? 2. 2 plus 2 4. 4 if it is steric number, then hybridization is sp3. So this is the process you have to use, and it is best method. Why I believe? Because sigma bond you can see here, lone pair you can see here, everything you can use from here. If any divalent element is there, then definitely they are going to make double bond. One is sigma, one is pi. That also you can find out from here only. So one thing I want to tell you, steric number, based on steric number, if it is steric number is 2, hybridization is sp. Steric number 3, then hybridization will be sp2. Steric number 4, hybridization will be sp3. If it is 5, sp3d. If it is 6, sp3d2. Okay, in case of sp3d, two angle will come 120 degree and 90 degree, and in case of sp3d it is all 90 degree octahedral molecule. So for 5 and 6 we are not going to talk here. We are going to talk only for sp, sp2 and sp3 hybridized molecule. Okay, so here only I am going to write their angle. How much is their angle? For sp, bond angle is 180 degree. For sp2 120 degree, for sp3 109 degree 28 minutes. Okay, now only you can see sp is the highest bond angle, then sp2, then sp3. So how it will help you, if you get three molecule and their bond angle, their hybridization is different, it is very easy for you to find out that sp is the highest, then sp2, then sp3. Okay, so let's take one more example to find out the hybridization. Suppose I am talking about sulfur dioxide, SO2. Okay, what is central atom? S. How many valence electrons? 6. 1 2 3 4 5 6. How many oxygen is there? 2 oxygen is there. One is here, one is here, and one lone pair is there. This is lone pair. So if I am going to count the steric number from this two bond, one bond only I will take as sigma. One sigma here, one sigma here. 2 sigma plus 2 lone pair equal to 1 lone pair. Sorry, 2 sigma plus 1 lone pair. That is total is 3. 3 means sp2. sp2 hybridized. Okay. So next I am going to directly tell you based on hybridization how you will find out different molecule and their hybridization. Okay. I mean based on hybridization how you will tell that which one is bond angle more and which one is less. Suppose you got BCl2, BCl3 and CCl4. These are the three molecules. Now you have to find out their hybridization. Okay, let's find out their hybridization. Here sp, here will be sp2, here will be sp3. You already know how to find out hybridization, so you do by yourself. Boron 3 electron is there, 3 chlorine making 3 bond. Steric number is 3, so it is sp2. In this case it is steric number 4, so it is sp3. Now you already know that sp bond angle is more than sp2 and sp2 bond angle is more than sp3. You already know this first concept, okay, from hybridization. So here you can say which one is bond angle more, which one is less. BCl2 more than this, then this. So this is your answer. Okay. And here only I want to tell, whenever I am writing something, you try to take a screenshot because I am going to rub and I am going to write again. So you have to be very fast. Okay, this is main concept, you have to remember that. Okay, so hybridization concept is up to there only. You should know how to find out hybridization and you should know their angle. And this angle, whatever I am saying that it is 120 degree, 109 degree, 28 minutes for sp3. These are bond angle when it is in ideal condition. Ideal condition in the sense there is no lone pair. Okay, so suppose here I am taking one molecule. This is methane molecule. This is carbon and 4 hydrogen is there. Okay, so in this case this all angle are 109 degree 28 minutes only. 109 degree 28 minutes only. If lone pair is coming, then concept going to change little bit. So next you will learn if it is any hybridization like sp3 and lone pair is there, then how to find out. Okay, so next is VSEPR. VSEPR. So let's, this one we have learned. Now we are going to learn second one. So valence shell electron pair repulsion theory. From there a lot of things is there. I am going to tell you the core things. That is, one concept is lone pair repulsion is more than lone pair bond pair repulsion. Okay, and lone pair bond pair repulsion is more than bond pair or single bond pair repulsion. Okay, so based on that we learned that if lone pair is there, their repulsion is more. Due to that our bond pair is going to reduce. So that concept we are going to use in different molecule. Okay, so let's take few example. Based on that we are going to do that. Number one example is methane, then another is ammonia and water. So the hybridization, this is sp3, this is sp3, this is sp3. You already know how to find that hybridization. Now lone pair. So why I was telling that use this method for find out hybridization, because from their method you can say the number of lone pair now directly. Okay, suppose for nitro and ammonia you are doing, nitrogen is the central atom. Okay, nitrogen central atom valence electron is 5. 1 2 3 4 5 and 3 hydrogen making 3 bond, 1 2 3 and 2 electron is there, that is lone pair. So 3 plus 1, 3 plus 1, steric number is 4. If it is 4, that is sp3. So advantage of this method is lone pair is there, you can see here only. So what are the lone pair? In case of methane, no lone pair, 0, here 1, here 2. So what is the main formula here? The main formula is if hybridization is same. Okay, hybridization, suppose hybridization is same for sp3 molecule. Suppose here also 3 hybridization, you can see same sp3 sp3 sp3, their lone pair is increasing. Number of lone pair on central atom increases, then bond angle, Ba means bond angle decreases. Okay, so you have to understand the logic. Suppose ammonia I am drawing here, 3 hydrogen is this way and 1 lone pair is there. Okay, due to that lone pair some repulsion will produce, and due to that this angle will reduce. What is the ideal angle for sp3 hybridized molecule? That is 109 degree 28 minutes. But in this case, due to this lone pair repulsion, this angle will reduce and it will be 107 degree. How much it is? 107 degree. For water molecule, oxygen will be here and 2 side atom is hydrogen, and in this case 2 lone pair is there. Okay, since 2 lone pair is there, the repulsion is quite more than ammonia. Okay, it is more than ammonia. So ideal angle for sp3 how much? 109 degree 28 minutes. But it is 2 lone pair is present, so it is angle will be 104.5 degree. Okay, it is lesser than ammonia. Definitely ammonia has 1 lone pair, it is 2 lone pair, so their angle should be reduced only. So here which one is most? Ammonia, that is methane, 109 degree 28 minutes, then ammonia, then water. Okay, you can take the screenshot, and this is the concept, BSEPR concept. Okay, in this case only one more thing I will tell you, that is NVPR. BSEPR is done. This concept when we are learning, when their hybridization is same but lone pair is different. Okay, due to lone pair repulsion is there. You can take the screenshot. Now here only few more things we are going to learn. Suppose hybridization is also same, lone pair also same, then what to do? Hybridization equal to same, lone pair also same. In previous case lone pair was different, 0 1 2. Here lone pair also same, then what to see? Then concept will come, two concept will come. Okay, one concept, A, central atom is same but surrounding atom SA is different. In this case what you need to see and what you need to do? So central atom is same, hybridization is same, lone pair is same. What is left? Left only surrounding atom. So in that case you have to see the surrounding atom electronegativity. Surrounding atom electronegativity increases, bond angle decreases. You have to remember this line. If hybridization is same, lone pair is same, central atom also same, what is left? Only surrounding atom is left, and surrounding atom electronegativity increases, bond angle decreases. I will give you one example. H2O, water. Let's take water only, H2O. Then one more example is OF2. OF2. Now if you see hybrid, 2 lone pair definitely there, both molecule, this 2 lone pair. Okay, hybridization how much? sp3 their lone pair how many? 2 lone pair. Central atom, what is central atom? Oxygen. Here also oxygen. What is different? Surrounding atom different. Here is hydrogen, here is fluorine. Now in between hydrogen and fluorine, which one electronegativity more? Fluorine is more. So electronegativity increases, bond angle decreases. So this fluorine electronegativity is more, so definitely fluorine, this molecule has lesser bond angle compared to H2O. So it will be this way. So now I will explain, you can take the screenshot, but I will explain how it happens. Okay, just this statement is not enough. You have to understand that why this electronegativity increases, bond angle decreases. So let's draw here. You see very nicely, this bond, it is a covalent bond, so definitely they have to share their mutual sharing and equal sharing should be there. But oxygen electronegativity is quite more compared to hydrogen electronegativity. Okay, so in this case what will happen? This shared pair of electron will be somewhat towards nearby oxygen compared to hydrogen. Due to that here delta plus and here delta minus also produced. Okay, so if you know this much, then you can imagine that since it is electron is somewhat near to oxygen. In this case also this electron is near to oxygen, this electron repulsion will produce. Due to that this angle will reduce. But in this case oxygen and fluorine, if you know the electronegativity, fluorine electronegativity is more than oxygen, so it will opposite. In this case it is opposite, it will electron will be towards nearby fluorine. Since it is also this way in nearby fluorine, this way also nearby fluorine, this distance is more. Since this distance is more, this repulsion is less. Okay, and in this case repulsion is more. Due to that this repulsion, this angle will be increased and this angle will be less. Okay, so here only one more thing I need to tell you, that this concept you can't use for all the molecules. Next, one more molecule I am going to show you here only, that is OCl2. Okay, let's draw here only, that OCl, Cl, definitely 2 lone pair is there. So now we can say again that compared to water and this molecule, electronegativity of chlorine is more than hydrogen. Since surrounding atom electronegativity increases, bond angle decreases. So this molecule, this compound should have less bond angle compared to water, but that is wrong. This molecule is more bond angle compared to water. Water is more than that. In this case this concept using, but in this concept is not useful and you are not going to answer from this concept. That's why people saying, students saying, sir, this is exception, this is exception, but it is not the case. So in this case this molecule is going to show NBEPR. What is NBEPR? Non-bonded electron pair repulsion. Okay, what really happened, that you have to see the surrounding atom. If surrounding atom is third period or more than that, third, fourth, fifth period of, or any alkyl group like R group, okay, any bulky alkyl group is there, then in that case this two molecules, since they are bulky, their repulsion will produce. Okay, due to that repulsion their angle is increasing compared to that. So you can't use this concept in this type of molecule, and don't learn this as a exception. Don't say that this is exception. This is not exception. This is under NBPR concept. Okay, not only this, if you are getting OCH3 whole 2, okay, ether like OCH3, obviously this repulsion will produce because of CH3. If you are getting OC2H5, OC2C2H5, this ethyl group is larger than methyl group, so here repulsion will be more than this one. So this thing you should know. Never say this is exception. This is not exception, this is under NBPR. Let's go to next concept. So you can take the screenshot. Next concept is, you take the screenshot. Central atom is different. Here central atom is different, but surrounding atom is same. Just make the opposite of that concept. Okay, surrounding atom is same. Then now you have to see the central atom, because central atom is different now. Central atom electronegativity increase, bond angle increase. Here I said now you make it opposite. Bond angle increase. So you see hybridization same, lone pair also same, surrounding atom also same. What is different? Central atom different. So we need to see, we need to observe only central atom. One example I am giving, again H2O, then H2S, sulfur, hydrogen, hydrogen. Here also 2 lone pair, here also 2 lone pair. Okay, 2 lone pair, everything is same. Okay, you understand already. So here electronegativity of oxygen and hydrogen, oxygen is more, so its electron will be towards nearby oxygen, and in this case sulfur is more electronegative than hydrogen, but compared to oxygen it is less. So due to that this repulsion is more compared to this one. Okay, obviously this one also it won't be nearby hydrogen, it will be towards sulfur only, but compared to oxygen it will be little far away. Oxygen will be more near to oxygen, this electron, and this repulsion is more. That's why this angle will be more. Okay, so this you can take as a screenshot. This is also done. So these are the main 3 concepts you have to use. First of all, hybridization. Second, hybridization with lone pair increasing, bond angle decreases. Number 3, is two part is there, A and this is B. Take it as a B. A was what? Central atom was same, surrounding atom different, but B is central atom is different, surrounding atom is same. In this concept, this is the concept you use. Okay, so you see the central atom electronegativity and use this concept. Okay, now last we have learned the NBPR. What is last? Dragos molecule. So let's learn about Dragos molecule. This is very interesting. Okay, this is very interesting. Dragos molecule. So some mnemonics I am going to use for this. Okay, so first of all, Dragos molecule means no hybridization. These are the molecules that are not going to show hybridization, not going to share their orbital. Okay, not going to mix their orbital. So this is no hybridization. They don't showing any hybridization. For N, you remember the N family, nitrogen family. For oxygen, you remember the oxygen family. For nitrogen family, one mnemonics is there that is in Hindi, but you can learn obviously. Nana Patekar, Vaisarya, Sub, Bindas. So like that, any mnemonics you can use. Usse tepo. Okay, oxygen, sulfur, selenium, tellurium, and polonium. So these are the molecules in nitrogen family and oxygen family. And for hybridization, you remember hydrides. Okay. So this whole Dragos molecule concept I am not going to tell you. It will take one class. I am going to finish in 2 minutes. We need to draw their hydrides. So NH3, PH3, ASH3, SBH3. Let's leave this last two, no need. In this case, H2O, H2S, H2SC, H2TE. So from among this all molecule, ignore nitrogen and oxygen containing molecule. Okay, these two you ignore. Why? Because they are in second period. Since they are central atom is second period, they are not big enough. For Dragos molecule, 2 to 3 things is required. One thing is central atom should be large. Central atom should be large in size. For that, it should be third period onwards. Okay. Second, surrounding atom should be small. Okay. And third, surrounding atom electronegativity should be less. Now, since they are asking surrounding atom should be small also, electronegativity also less, so this is very complicated, because one size is reducing, electronegativity is increasing, but like this only one element is there, that is hydrogen. Hydrogen size is small, electronegativity is also less. So that's why we are taking the hydrides of this all from third periods of nitrogen and third periods of oxygen. These are the molecules. So these are the 6 molecules that you have to remember, because they are not going to show hybridization. Since they are not going to show hybridization, so they will be stay as their pure orbital state only, that is px, py, pz, xyz. Okay, since we are talking about xyz, they are perpendicular to each other, so their bond angle will be around 90 degree. Okay, it is not exact 90 degree. This one is 93.8, this one 92.1, this one 91, this one 91 point something. So whatever it is, you just should have the idea that these are Dragos molecule and their bond angle is around 90 degree. So till now, whatever molecule I am discussed, among all these, Dragos molecule is always the least bond angle. I am telling you, this is one of the easiest way to find out the correct answer very easily out of 4 options. If Dragos molecule is there and they are in least, then that can be your correct option. Okay, because they are showing only 90 degree. Nobody is not going to show around 90 degree. Okay. So this is very important. Dragos molecule also done. So our concept is almost done. Everything is done. Now I am going to give you some tips. Some tips for competitive exam aspirant. Okay. So first of all, you should able to find out the hybridization, and based on hybridization you can arrange their bond angle. So sp will be higher than sp2, then sp3. Okay, so in case of sp3, NBPR may be possible. If NBPR is possible, then NBPR will come earlier, then other molecule will come. Okay, because NBPR electron, due to that bulky group, their repulsion will increase and their angle will increase. So NBPR you have to remember here, you can write star NBPR. Okay, NBPR, for NBPR it is only for sp3 hybridized. It is not only sp3 hybridized. The condition is sp3 hybridized should be, lone pair should be also present. If these two things are there, then only NBPR is possible, and surrounding atom should be third period onwards, or bulky group like R group, methyl ethyl, all this, then only it is possible. Okay, and once you done all this, at the end last will be Dragos molecule. Last will be Dragos molecule. So this is the pattern you must remember. And one thing I am telling you, whenever you go, you are seeing 3 to 4 option is there. After that, from that molecule, you see, first of all, you see the Dragos molecule is there or not. Okay, if Dragos molecule is there in out of that 4 option, in one option only they are showing the Dragos molecule least angle, that will be your answer. Okay, and you already know how to find out the answer. One question came in IIT JEE, I think. Yes, IIT JEE, that is NO2 plus, NO3 minus, NO2 minus. Out of this, which one is bond angle highest and least? Based on that, you have to find out. So you have to find out the hybridization. Nitrogen is 5, 1 plus, so 1 electron is gone, 4, that is sp. And here again 5, 1 electron coming due to that negative charge, 6, so that is sp2. And in this case 5, 1, 6, 6, 1 lone pair is there, that is sp2 only. Okay, but here lone pair is there, here is no lone pair. So what will be your answer? NO2 plus is the most bond angle 180 degree, then NO3 minus, NO3 minus, it is sp2 hybridized, there is no lone pair, so angle will be 120 degree. And in this case one lone pair is there, and it is angle will be around less than 120 degree definitely, so it will be NO2 minus. Okay, 5, 6, 6 means 4 electron, 1 pair is going and 1 lone pair is there, so this is the answer. So sometimes they are asking, in between they are giving NO2 also. So NO2, if you, it is odd electron species to find out the hybridization, that is a very interesting thing. 5 electron is there, 1, 2, 3, 4, 5, and how many oxygen? 2 oxygen, 2 gone, 1 electron is left. So it is not lone pair, it is only 1 electron. So what to do? This electron is going to count or not? So in this case is we are going to count, either you can give dative bond or just give this way to understand, and 1 electron is there. So due to that 1 electron, repulsion will produce, but that repulsion is lesser than NO2 minus. In case of NO2 minus, 6 electron is there. Let's draw here NO2 minus 6 electrons, so, and 4 electron gone, 2 electron will be this way. Okay, and see here this is lone pair, 2 electron, so repulsion will be compare more than this single electron. So single electron repulsion is less, but one surprising thing is 1, 2, 3, here also it is sp2 hybridized, here also it is sp2 hybridized. So this electron also you have to count, and here also you have to count. That is a totally different concept. This is getting delta positive and this is getting delta negative. Due to that, this electron you have to count. Okay, so this is also sp2, this is also sp2, but here angle is lesser than this one. So NO2, if they are asking NO2 also, then how you will arrange? How we will arrange? NO2 plus, obviously linear, it is the highest one. Then NO2 bond angle is, NO2 bond angle is 134 degree or 132 degree like that. Then NO3 minus, and then NO2 minus. So this way you have to arrange. So hopefully you got it. I tried my best. I don't know how much minute it is gone to explain all this. And kindly do share with your friends so that I can make more video. Thank you for watching. Do sharing and keep watching. Thank you.